Imagine a universe teeming with life, a vast cosmic expanse where humanity is just one of many intelligent species scattered among the stars. What would these alien civilizations look like? Would they have familiar features, eyes, limbs, expressions we can understand? Or would they be entirely different, beyond anything our minds can conceive? Now, imagine making first contact. Could we communicate with them? Would they perceive us as equals, or see humanity as an insignificant, primitive species? If they observe our history, our conflicts, our wars, would they even want to engage with us? Would they see us as potential allies, or as a dangerous anomaly, best left undisturbed? Throughout human history, we have looked up at the night sky and wondered, are we alone? Could intelligent beings be watching us from afar, studying our world, choosing to remain unseen? Or perhaps they are just as curious about us as we are about them. On the other hand, what if they do make contact? Would they come in peace, offering knowledge that propels us centuries ahead in science and technology? Or would their arrival mark the beginning of a dark chapter for humanity? Throughout history, when an advanced civilization encounters a less developed one, the results have often been tragic. Would history repeat itself, this time on a galactic scale? For now, these questions remain unanswered. But one thing is certain. If life exists beyond Earth, its discovery would be the most profound revelation in human history. A moment that redefines our place in the universe. Of course, this is all speculation. Just theories and dreams, right? Or is it? Welcome to the Milky Way, our home in the vast cosmos. It is a colossal collection of hundreds of billions of stars, stretching across 100,000 light years. But even this immense structure is just a small speck in the grand scale of the universe. Just how big is the universe? The numbers are beyond comprehension. Measuring it in miles or kilometers is meaningless, so astronomers use light years, the distance light travels in a single year. At 186,000 miles per second, light covers nearly 6 trillion miles in 1 year. To cross the Milky Way at the speed of light would take 100,000 years. And beyond our galaxy, there are billions, perhaps trillions, of other galaxies, each one containing countless stars and possibly even more planets. The light from the farthest galaxies takes billions of years to reach us. That means when we look up at the night sky, we are actually looking back in time, seeing the universe as it was billions of years ago, before Earth even existed. Scientists estimate there are more stars in the universe than grains of sand on every beach on Earth. Think about that for a moment. If even a fraction of those stars have planets, and if only a small fraction of those planets are in the right conditions for life, then the odds of Earth being the only inhabited world seem incredibly slim. In recent years, powerful space telescopes like Hubble and James Webb have helped us explore further than ever before. These observatories have revealed thousands of exoplanets, planets orbiting stars outside our solar system. Many of them are in what scientists call the habitable zone, the region where conditions might allow liquid water to exist, a key ingredient for life as we know it. One of the most promising discoveries is the TRAPPIST-1 system, which has 7 Earth-sized planets, 3 of which may be in the habitable zone. Could one of these worlds harbor life? And then there's Kepler 442b, a rocky exoplanet located 1,200 light-years away, which is considered one of the most Earth-like planets we've found so far. But the search isn't just about finding another Earth. It's about understanding how common life might be in the universe. Scientists are looking for biosignatures, chemical markers in exoplanet atmospheres that could indicate biological activity. With upcoming missions and advancing AI technology, we may soon have the ability to detect these signs of life more effectively. If we find a planet with an atmosphere rich in oxygen and methane, gases that shouldn't coexist unless life is replenishing them, it could be a game-changing discovery. With billions of potentially habitable planets scattered across the cosmos, the question isn't just if life exists elsewhere, but when we'll find it. Could we be on the verge of one of the greatest discoveries in human history? For centuries, humans have looked up at the night sky and wondered, are we alone? Are there other planets like Earth, orbiting distant stars, harboring life? For most of history, this question remained unanswered, but in 1995, everything changed. That year, astronomers discovered 51 Pegasi b, the first confirmed exoplanet orbiting a sun-like star. This gas giant, 50 light-years away, proved that planets exist beyond our solar system. Since then, scientists have identified thousands of exoplanets, some with conditions that could support life. Detecting exoplanets is no simple task. These distant worlds don't shine on their own, and their host stars often outshine them. But astronomers have developed ingenious methods to reveal their presence. Two of the most effective techniques are the transit method. When a planet crosses in front of its star, it causes a tiny dip in brightness. Space telescopes like Kepler and TESS have used this method to discover thousands of planets. The radial velocity method. A planet's gravity tugs on its star, causing it to wobble slightly. By analyzing shifts in the star's light spectrum, scientists can infer the presence of an unseen planet. Thanks to these techniques, we now estimate that almost every star in the galaxy has at least one planet. Many of these reside in the habitable zone, the region around a star where conditions might allow liquid water to exist, a key ingredient for life. Among the thousands of exoplanets discovered, some stand out as potential homes for life. Here are a few of the most exciting candidates. Proxima b, located just 4.2 light-years away, this rocky planet orbits within the habitable zone of Proxima Centauri, our closest stellar neighbor. If it has an atmosphere, it could support liquid water. TRAPPIST-1 system, a breathtaking discovery. 7 Earth-sized planets, 3 of which are in the habitable zone. Could this system be home to alien life? Kepler 442b, considered one of the most Earth-like planets found so far, with a strong possibility of liquid water and a stable atmosphere. LHS 1140b, a super-Earth in a nearby system, which may have a thick atmosphere capable of supporting life. Finding an exoplanet is just the beginning. To determine whether life could exist, scientists need to study their atmospheres. This is where the James Webb Space Telescope, JWST, comes in. Launched in 2021, JWST can analyze the light passing through a planet's atmosphere, detecting gases like oxygen, methane, and carbon dioxide, potential signs of biological activity. A critical discovery would be a chemical imbalance, similar to what we see on Earth. If we detect an atmosphere rich in oxygen and methane, 2 gases that shouldn't coexist unless life is replenishing them, it could be a strong indicator of alien life. The amount of data collected by space telescopes is overwhelming. That's why artificial intelligence, AI, is playing a crucial role in analyzing exoplanet data. AI can process massive data sets, identify patterns, and detect subtle signs of habitability far faster than humans can. AI is also helping SETI, the search for extraterrestrial intelligence, scan vast amounts of radio signals, searching for anything that might suggest an intelligent civilization is out there. The next generation of telescopes will take the search for alien worlds even further. Some of the most anticipated missions include the Extremely Large Telescope, ELT, a ground-based telescope capable of directly imaging exoplanets and studying their atmospheres in detail. The Habitable Worlds Observatory, HWO, a proposed NASA mission designed to detect Earth-like planets around Sun-like stars. The Breakthrough Starshot Initiative, a plan to send tiny laser-powered spacecraft to explore Proxima b, possibly capturing the first direct images of an exoplanet. While most searches focus on habitable planets, some scientists are looking for techno-signatures, evidence of advanced alien civilizations. These could include megastructures like Dyson spheres, giant constructs that could capture the energy of an entire star, unusual infrared emissions that don't match natural processes, artificial light pollution on exoplanets, similar to what we see on Earth. If we detect a signature that cannot be explained by natural forces, it could be evidence that we are not alone. With every new discovery, we come closer to answering the ultimate question: are we alone? Scientists are optimistic that within the next few decades, we might detect strong evidence of alien life, either in the form of biosignatures in an exoplanet's atmosphere or a signal from an intelligent civilization. For the first time in human history, we have the technology to find out. If life is out there, how long before we find it? And when we do, will we be ready? For decades, reports of unidentified flying objects, UFOs, have captured the imagination of the public. From eyewitness accounts to grainy video footage, the possibility that extraterrestrial visitors have already arrived on Earth is a topic of intrigue, speculation, and debate. But how much of this is real science, and how much is just fiction? Reports of strange aerial phenomena date back centuries. Ancient civilizations left behind records of mysterious objects in the sky, from the fiery chariots described in historical texts to the intricate artwork in medieval paintings depicting what some believe to be UFOs. However, modern UFO culture truly took off in 1947 when pilot Kenneth Arnold reported seeing a series of fast-moving, disc-shaped objects near Mount Rainier, coining the term flying saucers. Perhaps the most infamous case is the Roswell incident of 1947, where an unidentified object crashed in the New Mexico desert. While the U.S. military initially reported recovering a flying disc, it later retracted the statement, claiming it was a weather balloon. This contradiction fueled conspiracy theories that the government was covering up evidence of extraterrestrial life. The U.S. government has officially investigated UFO sightings multiple times. The most well-known effort was Project Blue Book, conducted by the U.S. Air Force from 1952 to 1969. The project analyzed thousands of UFO reports, ultimately concluding that most had mundane explanations such as aircraft, weather events, or astronomical phenomena. However, a small percentage of sightings remained unexplained. In recent years, the topic has gained renewed attention. The Pentagon's 2021 UFO report, based on data collected from U.S. military pilots, acknowledged that some encounters could not be readily identified. The U.S. Department of Defense also launched the All-Domain Anomaly Resolution Office, AARO, to continue the study of these unidentified aerial phenomena, UAPs, suggesting that the mystery remains unresolved. One major debate in the UFO community is whether these sightings represent alien spacecraft or advanced human technology. Some suggest that UFOs could be experimental aircraft from secret military projects, such as those developed at Area 51, a highly classified U.S. military base in Nevada, known for its secrecy. Others believe that the physics-defying maneuvers observed in some UFO sightings, such as sudden accelerations, right-angle turns, and silent hovering, are beyond the capabilities of human engineering, suggesting an origin beyond Earth. If true, such technology could revolutionize our understanding of physics and space travel. Beyond sightings, some individuals claim to have had direct encounters with extraterrestrial beings. The abduction phenomenon, popularized in the 1960s, includes reports of people being taken aboard alien craft, subjected to medical examinations, and later returned with fragmented memories. Skeptics argue that sleep paralysis and psychological factors can explain many of these cases, but some stories are remarkably consistent across different cultures and time periods. If extraterrestrials have indeed visited Earth, why haven't they made open contact? Some theories suggest they might be observing us from a distance, similar to how we study wildlife without interfering. Others propose the zoo hypothesis, which posits that advanced civilizations deliberately avoid interaction to allow humanity to develop naturally. Alternatively, it is possible that contact has already occurred but has been kept secret by governments to prevent social upheaval or due to the potential military advantages of recovered alien technology. With the advent of modern technology, UFO research is becoming more sophisticated. High-resolution satellite imaging, AI-powered analysis of aerial data, and space-based telescopes may soon provide clearer evidence regarding these unexplained phenomena. Regardless of whether UFOs are visitors from another world, secret military craft, or natural anomalies, one thing is certain: our curiosity about the unknown continues to drive humanity forward. The answer may be closer than we think. For decades, scientists have listened to the stars, hoping to catch a whisper from an alien civilization. We may not be able to see them, but could we hear them? This is the mission of SETI, the search for extraterrestrial intelligence. Instead of waiting for visitors, SETI scans the vastness of space for signals, potentially the first sign that we are not alone. In the 1960s, astronomer Frank Drake conducted one of the first SETI experiments, scanning the sky with radio telescopes to detect signals from intelligent life. The idea was simple. If an advanced civilization wanted to communicate, they might use radio waves, just as we do. Since then, radio telescopes have been used to scan distant stars, searching for narrowband radio signals, a type of transmission unlikely to occur in nature. Unlike random cosmic noise, a structured signal would suggest intentional broadcasting by an intelligent species. Today, advanced radio telescopes like FAST in China and Meerkat in South Africa are scanning the sky with unprecedented precision, covering billions of radio frequencies at once. In 1977, astronomer Jerry Amon detected something extraordinary: a 72-second radio burst from deep space near the Sagittarius constellation. The signal was so unique that Amon circled it on the printout and wrote one word: "Wow." Despite repeated attempts, the signal was never heard again. Could it have been a message from an alien civilization? Or was it just an unexplained cosmic anomaly? To this day, the WOW signal remains one of the most tantalizing mysteries in SETI history. The WOW signal isn't the only strange transmission we've detected. In recent years, astronomers have picked up fast radio bursts, FRBs, intense flashes of radio waves from deep space. Could they be the result of natural cosmic processes? Or is it possible that they are signals from an advanced civilization? Another mystery is Tabby's star, Kekiel IC 84622852, which experiences irregular dimming that some speculate could be caused by an alien megastructure, like a Dyson sphere, a theoretical construct built to harness the energy of an entire star. Unlike SETI, which only listens, messaging extraterrestrial intelligence, METI, takes a more proactive approach. It sends messages into space in the hope that someone, or something, will respond. Over the years, humanity has sent several interstellar messages, including the Arecibo message, 1974, a binary-coded message beamed toward a distant star cluster, containing information about Earth and human biology. The Voyager Golden Records, 1977, a set of sounds, music, and images placed on the Voyager probes meant to introduce Earth to any extraterrestrial finders. Recent METI efforts, such as the 2022 Beacon in the Galaxy, which included scientific and mathematical data designed for universal understanding. But is sending messages wise? Some argue that any civilization advanced enough to receive our signals would already know we exist. Others worry that we may be inviting unknown risks. The search for extraterrestrial intelligence is no longer just about pointing telescopes at the sky. Artificial intelligence is now playing a key role in analyzing massive amounts of data at speeds impossible for humans. AI-powered algorithms scan signals, looking for patterns that could indicate an artificial source. This technology is making SETI more effective than ever, helping astronomers filter out false positives and focus on signals that might truly be of extraterrestrial origin. SETI isn't just listening for radio signals. Scientists are now searching for technosignatures, signs of alien technology. These could include infrared emissions from Dyson spheres, structures built around stars to collect energy, artificial light pollution on distant exoplanets, similar to city lights on Earth, unusual planetary atmospheres, possibly altered by industrial activity. The James Webb Space Telescope is now scanning exoplanets for signs of biosignatures and technosignatures. If we detect an atmosphere rich in oxygen and methane, it could be a strong indicator of life, or even an advanced civilization. As our technology advances, the search for extraterrestrial intelligence becomes more promising. Each new discovery, whether a strange signal or a newly found exoplanet, brings us one step closer to answering one of humanity's greatest questions. Are we alone? If another intelligent civilization is out there, will we be the ones to find them? Or have they already found us? The answer may be closer than we think. For centuries, humans have looked at the planets of our solar system and wondered, could life exist beyond Earth? While we often imagine alien life thriving on distant exoplanets, we may not have to look that far. Some of the best candidates for extraterrestrial life could be right here in our cosmic backyard. Mars, our neighboring planet, has long been a subject of fascination. Once thought to be a barren, lifeless world, modern discoveries tell a different story. Scientists now believe that Mars may have once been home to vast oceans, rivers, and lakes. How do we know this? The evidence is written into the planet's surface. NASA's Curiosity and Perseverance rovers have detected ancient riverbeds, sediment layers, and mineral deposits that form only in the presence of water. These findings suggest that billions of years ago, Mars had conditions strikingly similar to early Earth. But if there was water, was there life? On Earth, where there's water, there's life. Even the most extreme environments, acidic lakes, deep-sea hydrothermal vents, are teeming with microbes. If life ever emerged on Mars, it may have been in the form of microbial organisms that thrived in its ancient waterways. Today, Mars is a harsh desert world with freezing temperatures and a thin atmosphere that offers little protection from radiation. But scientists are hopeful that remnants of past life, or even living microbes, could still exist beneath the planet's surface, where liquid water may still be locked away. The search for life on Mars is far from over. Future missions, including NASA's planned Mars Sample Return mission, aim to bring back soil and rock samples for analysis. The ESA's ExoMars rover is equipped with a drill capable of reaching 2 meters below the surface, where life may still persist, shielded from radiation and harsh conditions. If microbial life is found on Mars, it would be one of the most profound discoveries in human history, proof that life is not unique to Earth. While Mars offers clues about life in the past, one of the most promising places to find life today is Europa, a moon of Jupiter. Europa is a world of ice and mystery. Its surface is covered by a thick crust of frozen water. But beneath that crust lies a vast subsurface ocean, possibly holding twice as much water as all of Earth's oceans combined. Could an alien ocean be hiding life? Unlike Mars, Europa's ocean is not ancient history. It exists right now. Scientists believe that tidal forces from Jupiter's immense gravity create heat within the moon's interior, preventing the ocean from freezing solid. This process, similar to hydrothermal vents on Earth's ocean floor, could provide the necessary energy for life. Here on Earth, deep-sea hydrothermal vents, places where heat from the planet's interior meets ocean water, are thriving ecosystems, home to organisms that survive without sunlight. Instead of relying on photosynthesis, these life forms use chemosynthesis, drawing energy from minerals in the water. If similar conditions exist on Europa, microbial life could be thriving in its dark ocean, living off chemical reactions near underwater vents. NASA's upcoming Europa Clipper mission, set to launch in the 2030s, will conduct multiple flybys of the icy moon, using radar and spectrometers to study the ocean beneath the surface. Scientists hope to detect plumes of water vapor erupting from the ice, which could provide direct evidence of organic compounds and potential biosignatures. Mars and Europa represent two different possibilities in the search for alien life. Mars offers evidence of a past habitable environment, while Europa may be habitable right now. Both worlds hold immense scientific potential, and the coming decades may finally give us the answer to the question: are we alone? If life exists in our own solar system, what would that mean for the rest of the universe? As we search for life beyond Earth, one place stands out as particularly intriguing: Titan, Saturn's largest moon. Unlike any other world in our solar system, Titan has a thick atmosphere, vast lakes of liquid methane and ethane, and a rich chemistry that may hold clues to the origins of life. Titan is unique. It is the only moon in the solar system with a dense atmosphere, composed mostly of nitrogen with traces of methane. This thick, hazy atmosphere makes Titan look like a distant cousin of early Earth. But what truly sets Titan apart are its lakes and rivers, not of water, but of liquid methane and ethane. Temperatures on Titan plunge to -290 degrees Fahrenheit, or -179 degrees Celsius, far too cold for liquid water to exist on the surface. Yet, despite its frigid environment, Titan is a world that appears to be active, dynamic, and, perhaps, capable of hosting life. Life as we know it depends on liquid water. But what if a different form of life could survive in liquid methane? Scientists speculate that Titan's lakes might support methane-based organisms, creatures that do not rely on water, but instead use hydrocarbons as a biological solvent. On Earth, all known life forms rely on water for biochemical reactions. But Titan challenges this assumption. If life can develop in liquid methane, it would mean that life in the universe could be far more diverse than we ever imagined. Could Titan be home to an alien biochemistry completely different from anything on Earth? In 2005, the Huygens probe, part of the Cassini mission, made history by landing on Titan's surface, the first and only spacecraft to land on a moon beyond Earth's own. The data it sent back revealed a landscape eerily familiar yet profoundly alien. Dunes, riverbeds, and vast lakes of liquid hydrocarbons. Huygens also confirmed that Titan experiences methane rain, creating seasonal weather patterns similar to Earth's water cycle. This means that Titan has an active hydrocarbon cycle, where methane evaporates, forms clouds, and falls back as rain, just like water does on Earth. To unlock Titan's secrets, NASA is preparing Dragonfly, a drone-like spacecraft set to launch in 2027. Unlike traditional rovers, Dragonfly will fly across Titan's surface, sampling different environments, analyzing organic molecules, and searching for chemical signatures of life. If Titan harbors even the simplest methane-based life, it would revolutionize our understanding of biology and the possibilities for life across the universe. If life exists on Titan, it would be unlike anything on Earth. But could Titan-like conditions actually support life? To answer this, scientists look to extremophiles, organisms that thrive in some of the harshest environments on our planet. If life can adapt to Earth's most extreme conditions, it's possible that similar adaptations could exist on Titan. Titan challenges our assumptions about where life can exist. It is a world that shows us that life does not necessarily need Earth-like conditions. Perhaps it only needs the right chemistry. For decades, scientists have searched for life by looking for planets that resemble Earth. But Titan reminds us that life may not always follow Earth's blueprint. Instead of limiting our search to Earth-like worlds, we must expand our perspective to include exotic biospheres, places where chemistry and conditions are radically different, yet still capable of supporting life. If life can exist on Titan, then life could exist almost anywhere. How many other hidden worlds, even in our own solar system, might be waiting to be discovered? For centuries, humans have wondered, what would happen if we made contact with an extraterrestrial civilization? Would it be the greatest moment in human history, or the beginning of a new, uncertain era? As we search for life beyond Earth, scientists are preparing for the day when we finally receive an answer. But how exactly would first contact unfold? And are we ready for the consequences? There are multiple ways we might detect an intelligent extraterrestrial species. The most likely scenarios include radio or optical signals. Just as we broadcast TV and radio signals, an advanced civilization might send out messages that travel across the cosmos. SETI has been scanning for such signals for decades, hoping to detect an artificial transmission. Technosignatures. Instead of direct communication, we might detect the presence of an advanced society through their impact on a planet's atmosphere, or unusual light emissions from megastructures like Dyson spheres. Physical artifacts. Space probes or remnants of alien technology might already be floating in our solar system, waiting to be discovered. If we detect an alien signal, the next question is, should we respond? The scientific community already has protocols in place for what to do if we detect an extraterrestrial signal. The SETI post-detection protocols, developed by the International Academy of Astronautics, outline the steps to be followed. Verification. Scientists must confirm that the signal is truly artificial and not a false alarm caused by human interference or natural cosmic phenomena. Independent confirmation. Other observatories and researchers must validate the discovery to rule out errors. Public disclosure. Unlike in movies where governments hide alien contact, the protocol encourages full transparency with the global scientific community. No immediate response. Scientists have agreed that humanity should not send an immediate reply until global discussions take place. But what happens next? That's where things get complicated. While some scientists argue that we should actively send messages to the stars, others, like the late Stephen Hawking, strongly disagreed. Hawking warned that if an advanced alien civilization discovered us, they might not have good intentions. He compared the situation to the arrival of Europeans in the Americas, where the encounter led to the destruction of native civilizations. If an alien species is millions of years ahead of us, they might see us as insignificant, or as a potential resource to be exploited. Would an extraterrestrial species see us as equals, or as primitive beings? Would they be peaceful explorers, or something far more dangerous? If we do make contact, what happens next? Scientists have outlined 3 major scenarios. They don't respond. If we detect an alien civilization, but they choose not to communicate, we may never know their intentions. They might be observing us, or they may have rules against interfering with less advanced species. Friendly contact, the best-case scenario, a peaceful exchange of knowledge, ideas, and culture. This could propel humanity into a new era of scientific and technological progress. Hostile intentions. The worst-case scenario. If their goals conflict with our survival, we might face a challenge far beyond anything we've encountered before. Each of these possibilities raises ethical and philosophical questions. Should we prepare defenses? Should we attempt diplomacy? Or should we simply remain silent and observe from a distance? Whether first contact is peaceful or not, it will change humanity forever. The psychological impact could be profound. Religious and cultural shifts. Every major religion and belief system would have to reconcile the existence of another intelligent species. Political and social reactions. How different nations react could shape global alliances and conflicts. Scientific revolutions. Contact with an advanced civilization could introduce us to entirely new branches of science and technology. Would humanity unite, or would we struggle with fear and division? First contact wouldn't just be a scientific event. It would be a turning point in human history. As we improve our ability to search for extraterrestrial life, governments and institutions are starting to take first contact more seriously. NASA, SETI, and international organizations are already developing strategies to handle a confirmed discovery. Future missions, like the James Webb Space Telescope, are analyzing exoplanet atmospheres for biosignatures, evidence that life exists elsewhere. If we detect life, the next step is understanding whether it's microbial or intelligent. Meanwhile, projects like Breakthrough Listen and AI-powered SETI searches are increasing the chances that we will hear a signal from an advanced civilization in our lifetime. If tomorrow, we confirmed the existence of an alien civilization, how would you react? Would you feel excitement, fear, or curiosity? Would you support sending a message? Or do you think we should remain hidden? One thing is certain: the moment we make first contact, everything will change. It will no longer be just science fiction. It will be reality. The question isn't if we will find extraterrestrial intelligence, but when. And when that day comes, will we be ready? The universe is vast, so vast that our Milky Way galaxy alone contains hundreds of billions of stars. Beyond that, there are trillions of galaxies, each filled with countless planets. Given these staggering numbers, the question arises, if intelligent life is common, where is everyone? This is the essence of the Fermi Paradox, a contradiction between the high probability of extraterrestrial civilizations and the complete lack of evidence for their existence. Scientists estimate that there could be millions or even billions of potentially habitable planets in our galaxy alone. Even if a tiny fraction of these worlds developed intelligent life, there should be civilizations far older and more advanced than ours. Based on this assumption, at least one of the following should have happened. We should have detected radio signals from an advanced alien society. We should have found physical evidence of alien technology. Someone or something should have visited us by now. And yet, we see nothing. This is what makes the Fermi Paradox so perplexing. There are many theories attempting to explain why we haven't encountered extraterrestrial civilizations. Let's explore some of the most compelling possibilities. What if we are among the first intelligent species in the universe? The conditions for life may be common, but perhaps the jump from simple microbes to intelligent civilizations is exceedingly rare. If this is true, humanity might be one of the first civilizations to emerge. A lonely pioneer in an empty cosmos. Space is unimaginably vast. Even if alien civilizations exist, they could be millions of light years away. With current technology, we wouldn't even detect them. Communication across such distances would take thousands or even millions of years, making meaningful interaction nearly impossible. One of the most unsettling solutions to the Fermi Paradox is the idea of the Great Filter, a point in evolutionary development that most civilizations fail to pass. This could occur at different stages. Before intelligence develops, maybe life itself is incredibly rare, and the conditions that led to intelligence on Earth were a fluke. After intelligence emerges, civilizations might have a tendency to self-destruct before they reach interstellar capabilities. Nuclear war, environmental collapse, or uncontrollable artificial intelligence could wipe them out before they expand into the galaxy. If the Great Filter lies ahead of us, then humanity could be on a dangerous path, facing an inevitable collapse before we ever reach the stars. Another theory is that alien civilizations know about us, but choose not to make contact. This idea, known as the zoo hypothesis, suggests that more advanced species observe us from a distance, similar to how humans watch wildlife in nature reserves. Why wouldn't they reach out? Perhaps they believe interference would disrupt our natural development. Or maybe they see us as too primitive to engage with. What if we've already made contact, but we just don't recognize it? Some believe that aliens could be here right now, disguised in ways beyond our understanding. This theory suggests they could be using cloaking technology, hiding from our instruments. They may exist in dimensions or forms beyond human perception. They could have visited in the distant past, influencing ancient civilizations. While no concrete evidence exists to support this theory, the possibility keeps researchers intrigued. Despite the mystery of the Fermi Paradox, the search for extraterrestrial intelligence continues. Scientists are expanding the search for biosignatures, chemical indicators of life, on exoplanets. The James Webb Space Telescope is already scanning distant worlds for atmospheric signs of biological activity. Meanwhile, projects like Breakthrough Listen are using AI to analyze radio waves from deep space, hoping to catch even the faintest whisper of an alien civilization. Perhaps we haven't found life yet simply because we haven't looked in the right place or in the right way. Or maybe, in the grand scale of the universe, we are still infants, waiting to grow into a species capable of understanding what's truly out there. The Fermi Paradox forces us to confront the biggest question of all. Are we truly alone? If we are the only intelligent beings in the cosmos, then we carry a great responsibility to explore, to protect our planet, and to ensure the survival of our species. If we are not alone, then the silence of the universe remains a puzzle waiting to be solved. So, where is everybody? The answer may change everything we know about our place in the cosmos.